Hello everyone, my name is Christine and welcome to the design course of Grasshopper in the University of Queensland. Today we are going to have a brief introduction to a parametric design tool called Grasshopper. It's a plugin for Rhinoceros. I hope some of you are familiar with digital design in general and may be acquainted with Rhinoceros. Grasshopper is a graphic algorithms editor connected to Rhino tools. Unlike RhinoScript or Python, Grasshopper doesn't require knowledge of abstract programming syntax. In contrast to scripting platforms for algorithm design, Grasshopper has a visual interface in which development of an algorithm could be seen like a flow chart and allows users to create generative forms from basic and primitive ones to complex and breathtaking structures. Just keep in mind that the Grasshopper forum is very lively and active. The whole community is quite friendly, so you might like to check out the Grasshopper 3D website forum on a certain point. Contemporary designers are dealing with algorithms as the model of computation to do their design tasks. An algorithm is a set of rules and instructions in a step-by-step procedure to calculate, process data, and do a defined task. For any piece of data as input, an algorithm will perform its predefined operations and calculate the result. In this sense, a design algorithm will also provide a design output if being fed by relevant information input. We are performing tasks using algorithms in everyday life. Actually, any task can be described as an algorithm. Making a cup of tea is an example that illustrates my point. To make a cup of tea, we need to take a bag of tea, boil water, put it into a cup, put tea into a cup containing boiled water, add sugar if needed, and here we go, a cup of tea. Algorithms we'll be using in Grasshopper have similar logic. It works from left to right, just the way we read and write in English, and we start with basic shape and transform it and take steps to get the result we want. Now let's jump into Rhino and open Grasshopper. In Rhino version 5, you need to upload the plugin and put it there. In version 6, it's already incorporated in Rhinoceros. We will be using Rhino 5 now, so here we need to type Grasshopper, and here we go. I strongly recommend you to locate your windows the same way so you will see the outcome of your actions here in this window while you're putting components and making your script here. So let's get started. There are different types of components in Grasshopper which are divided in component tabs over here based on their geometry or function properties. It can be curve, surface, transform. Functions, commands, and geometry operations are sorted in these components, so the design algorithm should be set up using them. To make everything simple, most of components can do one of the following functions. They can provide data, manipulate and modify data, draw objects, meaning geometry, and modify objects. A normal component has two sets of ports. So let's take a geometry tab, take a point from here, point. It has input on the left, where it receives data, and output on the right, where it provides results. Some components are different because of the nature of the work that they perform. Right-click on the component will open a menu which has some of the controlling features of it. The last part of this menu offers you a help option that contains some basic descriptions of the component's function. And the first option lets you set the name of your component. If you like to change or customize it, we can name it any way we want. Let's say point 1. Okay, done. Then we can hide or unhide it. We'll get to that later. And let's start with a really basic operation that will allow you to understand how it works. So we need to define external geometry. One of the most important resources of input data is geometry. Let's say drawn objects from Rhino workplace, so from here. It could be a point, a curve, a surface, a drawing, plan, section, up to multiple complex objects from any source that exists in Rhino. Any geometry in Grasshopper needs a component in canvas. It's here, it's called canvas, and here are the components. So it requires components on canvas in order to make it work. And it's all contained in these tabs here. By introducing the point here, we set it only in Rhino, and it doesn't exist in Grasshopper yet. So to introduce them to each other and link them together, we need to right-click on the component in Grasshopper, select Set One Point, and select the point from Rhino. Here it is. As you can see, the component of the point here changed its color from orange to gray. So let's talk a bit about the color encoding that exists in Grasshopper and shows how components work and their status. Any gray component, like this one right now, means there is no problem and the data defines correctly and the component works correctly. The orange, let's do it like that. The orange shows a warning and it means there is a problem that should be solved, but the component still works. So here you can see a prompt what you should do and why doesn't it work. Now it has no geometry and that's why it's orange. That's why it doesn't know what to do. While this point has its geometry defined in Rhino and it's light gray because it works. Your component may be red and it means that there is an error and the component doesn't work in this situation. The source of error should be found and solved in order to make component work properly. The green, okay, now we choose that it's green. The green color means this component is selected. So it's green here and the point is green here. Easy. Then the geometry which is associated with this component is also green too, while it's dark gray if the preview is disabled. So middle button on your mouse, click disable preview, and it's dark gray now because we have hidden it. So we'll come to that on the other stages. Let's unhide it again. If you know the name of the component you want to use, or if you want to search it faster than shuffling components tabs from here, like you need to find it here, get there, find it, choose it. It takes some time, you know, and you can just double click on the canvas and type in the name of the component to bring it on. So point. It's way easier and just a nice trick to use when you are familiar with the Grasshopper. Now when we defined the geometry for this point, let's do the same and make 2 more points. So we have to input geometry in Rhinoceros, right click, set one point, let it be this one. The same operation with this, and done. Now let's make a triangle. Now when we have 3 points of our triangle, we need lines that connect the points. To make it, we go to curve and choose line. We don't choose it from params, while there is a line too, because this one requires geometry from Rhinoceros. It's a special component, and this one will create it. So what do we do next? Quite logically, we connect points. Here we have input, line start point and line endpoint. It's really intuitive. Let's just Ctrl+C, Ctrl+V works here, just so you know. We'll need 3 lines because we have 3 points from left to right, connecting points. Our component is selected now, so it's green. Here is the line. Keep going and let's connect other 2 points with a line. Here it is. And the last connected lines, here we go. What would I like to explain here, that we can manipulate our points in Rhino and we will still have our triangle in Grasshopper. This happens because the triangle is now an algorithmic triangle, which is generated based on the relations between elements of design rather than being drawn manually. The algorithmic relationship defines how geometries should be generated in design field. Nice and really intuitive logic. Great thing to do.